lot of vocab today, so make sure you guys are following along. They're vocab, but they're super important, okay? You need to understand these in order to answer the examples or questions. There were two of you asked me, hey, I can't print. Can I do notes online? Yes, do notes online. Okay, take out a piece of line paper. Old school. Who cares? All right. So yesterday, the video notes ended at vocab 3. Am I correct? Okay. Power function of degree n, aka, what's aka? Also called n behavior. In algebra 2, okay, I believe that your teacher taught you n behavior as like up, up, right? Or up, down. Now in this class, n behavior is going to be an equation. You will not need to tell me up, up, or up, down. Okay, it's going to be an equation format. So, properties of power functions. Okay, so if you don't have printed notes, take out line paper, please. So properties of power functions. F of x equals x to the nth power. Okay, n is an even integer. Okay, so here we go. Let's fill this out. 1. F is an even function. That means it's symmetrical about what? About the y-axis. Symmetry about the y-axis. Okay. Now, what is the domain of an even integer function? Give me an example of an even number. 4. What else? 2. What else? 12. Yeah, 12. So, f of x equals x to the 12th, like that, right? Or x squared, or x to the 6th. Okay, that's one of those. What is the domain of an even integer function? Greater than 0? Equals to 0? Domain? Can I pick -1? When x is -1, y will also be? What's y when x is -1? 1, right? Because any negative number, when you square it, it will always be positive. So the domain is all reals. Okay. What is the range? What's the range? What happens when you pick negative values for the domain? It's always what? Greater than 0, right? So the range is always greater than or equal to 0. Okay. F always, yes.
I have a question. Since n is an even integer,
Uh-huh.
but like 0 is even.
Sure. 0 isn't even. In this case, we're going to say the n is going to be greater than 1. Okay? Because what happened is 0 is not a funny, it's a boring equation. Yeah. Okay, F always has 3 points. What's your easiest point that you would like to choose? 0. When x is 0, y is also 0. What else? 1, 1. Okay. What else? -1. When you plug in -1, what would you get? 1. Okay. So that's why y is greater than or equal to. Okay. As n, okay, what's n in this? What does n represent in this box? An exponent. Okay. Because n is an exponent. N is an exponent. As n increases, bless you. So for example, we can have y equals x squared. Y equals x to the 4th as n gets bigger and bigger. Taylor, you doing okay back there? Okay, take notes. The graph, okay, as n increases, the graph increases more rapidly. Okay, that means it goes faster. So an x squared is going to have not an increase as fast as x to the 10th. Okay, so as n increases, the graph increases more rapidly when, this is where I'm going to answer your question, when we pick x values that is less than -1, or we pick x values that are greater than 1. Okay? But for values of x, okay, but for x near the origin, the graph tends to flatten out. Okay, and lies closer to the x-axis. Okay, so what is that? So it's talking about y equals x to the n, where n is 2, 4, 6, 8, any number, an even number that you want to pick. Okay, so let's compare x squared and x to the 10. Which one will have more rapidly? Which one can increase faster? X to the 10. You're right. Okay, the exponent is a lot bigger. So the bigger the exponent, the faster it goes up. Okay. Now, except near the origin. That means from -1 all the way to +1. What's going on with x to the 10? Is it flatter? What's going on near the origin? Yeah, it gets flatter because why? What if I pick x? What if x is 1/2? 1/2 to the 10 versus 1/2 squared. Which one will give you a smaller outcome? 1/2 squared or 1/2 to the 10? Yeah, 1/2 to the 10 is going to give me a smaller outcome, right? So that's why it says except near the origin, from -1 to 1. It's flatter. That means it's closer to x-axis because the output is a lot smaller. Okay, so that's it. All right. What if f is an odd function, like x squared? Next box, right? It's not an odd function. My bad. X to the 3rd, x to the 5th, x to the 7th. Okay. How is this different from if it's an even function? So, i.e., what if we put x, f of x equals x to the 3rd? F is an odd function. That means it's symmetric about? Symmetric about what? X-axis? The origin, right? About the origin, which is x and y. Okay. What is the domain of all odd integer functions? All real. I can pick negative, I can pick positive, whatever I want to pick. Okay. What's the range? Also all real, because when -1 you plug into an odd function, it's gonna be negative, so all reals. This also contains 3 points. Give me the nice 3 points. 0, 0, 1, 1, -1, -1, because the range is all reals. Okay. Then everything else is exactly the same as even. Okay. It grows more rapidly if the exponent is bigger, except near the origin, okay, from -1 to 1. The bigger the exponent, the flatter it is. Okay. So this is where I'm going to ask you to take out your calculator and do the 2 boxes. I'll project it bigger because I know not everyone has printed notes, so I'm going to wait a little bit. Now, if you have printed notes, do box 1 and box 2 on your own, or actually with your team would be great. Do we know how to get the points from the calculator to graph or to plot on your paper? So I'll move it up as soon as students are done copying. So on the same screen of your graphing calculator, you and your team talk it out, work it out. Okay. Compare the 2 even functions. That's x, y equals, is that x to the 2nd? Or is it x to the 2nd? And then plot it out there. I'm asking you to graph it using X window from where to where? -4 to 4 and hit graph, okay? Okay, I'm gonna move up. Here we go. So do both, okay? Both left and right box. So you and your team, when you have a graph, can you please show it to your partners or your teammates so that way you guys are all on the same page before we start plotting happily?
Oh, okay.
Don't forget to change your window. Your window, I want it to be from just the X, -4 to 4, okay? You should have two graphs, right? Two curves on there.
Maybe this.
I think you should.
Million. I don't think just leave it from negative 10 to 10. I think graph is enough. Just graph. No, just graph. Because you put even window. So just graph it. Because you did negative 10, positive 10 y.
Okay, once you have it, can you please sketch out on your paper, your notes? Sketch both, please. Okay, the even and odd. Remember, you can use what? Where do you go to get the point to help you plot? Yeah, use your table. The calculator has tables. It's very helpful when you have to use it for sketching. How do you change it so you can see where the halves are? Where do you go? Table set. Okay, so second table set, which is the window. Okay, if you want to change it to halves, you can also do that. So once you're done graphing the even ones, do the odd one. Does it look pretty flat near the origin? Yeah. So bigger excellent ones. Yeah, so the table start is what time you want to start. Let's say like negative 10. That's what value you want to pop up over here. The delta is what you want. You can do like 0.5 or 0.25. And then the delta is the value that you want the increment to be. The start, the table start is like, hey, what is the first value you want to see on the table? Okay, so we should all have something graphed already on the even ones. As I was walking around, most of us have this, right? Yeah, which one is the flatter one? The x to the 10th or x squared? Yeah, actually, look how flat this is. It's like really close to the x-axis. And I believe it's the same thing for x to the 3rd, right? If I give you x to the 3rd, okay, and then x to the 7th. Okay, and so if I just zoom in on the window from -4 or even closer, I have two colors here, the green and the orange, and notice how the orange one is so much flatter, okay, than the x to the third. So that's why it says it's really flat near the origin, okay? Okay, so make sure we have both sides plotted and graphed. Raise your hand if you need more time in sketching that out. Sure, yep, I'm not going to rush you. Take your time. And then once you're done graphing that out, we have a few more vocab to get through. Yes?
You're like in the millions. Just do the Y window maybe. Excellent.
So you don't really.
Not really, especially if we're trying to get to that. Right, you're winning student. You're like in the 104 millions on Y. So just do from negative 10 to 10 on Y.
I think most of us are done with that. All right, let's vocab number 4. Real zero. Here we go. Give me another terminology that we have used for real zeros before. X-intercept. Give me something else that we use for x-intercept and real zero before. Root, right? Those are solutions. Root, yep, they are all looking for the same thing. So here we go. Real zero. And this is formally defined, okay? And then we'll talk about non-formal. If f is a function and r is a real number, for f of r equals 0, okay? So if f is a function and r is any real number, f of r equals to 0, okay? So that happens. Then r is called a real zero. Of f, okay? We're going to write some more, and then let's talk about this first. So, remember, real zero is just called x-intercept. How do we find the x-intercept? Set y equals to 0. So, guess what? Y in this case is what? Is 0. So if you set y equals to 0 and you come up with a value, okay, then that value is an x-intercept. But if I plug that value back into my function, it should equal to 0. That's all that is, okay? So r is a real number. If I plug it into my equation and it equals to 0, then that is a root. That is a solution. That is an x-intercept. Is that understood? Okay. Now, so I'm going to write all those AKAs down for us. AKA, okay? A real zero is also called an x-intercept. Okay? Or, one of you said earlier, Kari, a root, right? And it's also called a solution at times. Would you agree? Okay? A root and a solution. Okay? So those are all talking about the same thing. Now, this is piggybacking on what a real zero is. It's called zero multiplicity. So zero multiplicity is when the factor, x minus r, that's a factor of the function, okay, occurs more than once. Okay. If x minus r to the nth is a factor, then r is a real zero multiplicity m of function f. Okay. And we'll do like a quick example. So i.e., what am I really talking about? If I give you f of x equals x minus 8 to the second power. Have we seen this before? Yeah, what curve? You might have to graph that out. What curve would that be? A parabola. That's right. Where's the vertex at? 8 comma? Perfect. 8 comma 0. Can we all agree with that? If I could solve, what would you say? How would you solve it? Uh-huh. Yeah. Isn't the answer simply 8? You take it, you say equal to 0, right? So this one said, hey, 0 multiplicity. So your root, your answer is 8. But the square power, technically, the square power means how many of those do I have? The square power means 2 of those, right? But when in algebra 1 and algebra 2, we kind of ignored them. We no longer can do that, okay? This is when it says the real 0, okay, so the 0, it's 8. X equals 8. Multiplicity twice, okay, 2 times. And that number 2, the multiplicity is going to have meaning, like right now, number 6. Even multiplicity. What does it mean? Why does it have significance, okay? Even multiplicity. The sign, bless you, of f of x, okay? What's another variable I can use for f of x? Y, okay? The sign of f of x does not change from one side of r to the other side of r. Okay, and this is really the most important. The graph touches x-axis at r, okay? Okay, so for the sake of argument, we are going to graph out or sketch out what we came up with, the i.e. above. F of x equals x minus 8 squared. So you guys told me earlier that the vertex is at 8 comma 0. Okay, 8 comma 0. Then I'm just gonna need a couple more points. Okay, when x is 9, 9 minus 8 is 1. 1 square is 1, right? Because parabolas are symmetrical, so would you agree that I'm just gonna plug a dot on that side as well? So this is what it looks like for y equals x minus 8 quantity square. All right. What does it mean when the definition is the sign of f of x does not change? What does that even mean? Okay, what's r in this particular example that we just randomly came up with? What's r? R is 8. Okay, r is 8 because r is where the 0 is. Here's 8 for the sake of argument. R equals 8. Yes, no, maybe? The sign doesn't change. What does it mean by the sign doesn't change? Yeah, the sign of f of x. By the way, f of x, give me another variable. Y. What is on one side of r? What's the sign on this side of r? Positive or negative? Positive. Go to the other side of R. It's also positive. That's what it means by the sign. Here, this is positive. This is also positive. The sign of Y does not change from one side of R to the other. It says the graph touches x-axis at R. Is that true? Is it touching the x-axis at R? Yes, that's what it means, okay? That's why the even multiplicity has that significance. It's that if it's even, it will always touch the x-axis at R, okay? Then let's talk about odd. What if it's not even? Like it's odd, okay? So here we go. Let's define it and then we'll give it an example. The sign of f of x changes from one side of R to the other side of R. Okay. Now,
Is R always the vertex?
R is not the vertex. R, it's actually and yeah, good question. What is R, class? R is not always the vertex. R is a real zero, like a root, an x-intercept. In this case, it happens to be the same, but it's not always true. Okay? All right. Okay, so if it's an odd multiplicity, okay, the signs will change from one side of R to the other. Okay, and this is important. Here we go. The graph crosses the x-axis at R. Okay, so we'll come up with an example, something that we already know. F of x equals x to the third. I think we can all relate to this. Can you find the x-intercept here? What's the x-intercept here? 0. Okay, I'm gonna stop right there. Is that okay? But it's 0 how many times? 0 to the third, isn't it? So technically, couldn't I say x-intercept 0 multiplicity of 3? Okay, so that's why it's called odd. Well, we all know how to graph this out. When x is 0, y is 0. X is 1, y is 1. X is negative 1, y is negative 1. Okay, so here's the graph. Nice and simple. Again, R is 0, right? Multiplicity 3 times. Does it cross? Does it touch the x-axis at R? It does what? It crosses. So that's why odd multiplicity will always cross. Okay? Even multiplicity will always touch. Okay? All right, turning points is our next definition. Turning points, okay, are points where the graph changes from increase to decrease or vice versa. Okay, so where it changes from increase to decrease. I'm just going to make up like a graph really quick. Okay. Make a point at negative 3, 0. Just from the random point. Okay. Oh, it's sleeping. Can you hit the keyboard for me? Thank you. All right, so make a point there. Make another point at 0, negative 5. 2, 4, 5. Make another point at 3, 0. So like that. Okay. Just these are random dots. And then let's curve that down. Let's shoot up this way. Oh, let's make that way. All right, here we go. So here's a made-up function that we just have. Okay, so it says turning points are where the graph changes from increase to decrease. So how many turning points do we have based on that definition alone? 2. Is this increasing? Good. And then all of a sudden is? So is that a turning point? Yes. It's decrease and then all of a sudden it So that's also a turning point. So there are two turning points in here, okay? So let's talk about turning points. If f has a degree, let's call it n, right? A degree exponent in this notation is called n. Then f has at most n minus 1 turning points. Okay. Let's talk about that, what it means, right? Because formally, some of us are not going to understand. If I have y equals x to the 8th, what's the degree? X to the 8th, what's the degree? 8. That means I can have at most how many turning points? 7. It's n minus 1, right? How about the other way around, the converse, aka, if the graph has n minus 1 turning points, let's say, if you know the equation has 4 turning points, what is the degree that it may have? 5. It's backwards, right? Would you agree? So if you know that it's 4 turning points, then you can go back and go backwards. So it says, hey, the converse is also true. But the converse of the word at most is what? At least. Okay, so aka if the graph has n minus 1 turning point, then f has at least n degree. Okay, it's always one more degree than its turning point. Okay, last vocab, and then we can go to examples. N behavior, we kind of mentioned this already in the video notes. N behavior is aka what? AKA N behavior. Up or down, that's what we used last year. But in the video notes, what else did we use for N behavior? Tom?
Power function.
Power function. You're right. Here we go. N behavior for large like values of x. Okay. You can have negative 1 million for x, either positive or negative. It doesn't matter what you pick. Either positive or negative. Okay. The graph of the polynomial the graph of a polynomial function. And then I'm just going to give you the definition of a polynomial function from your book. A subscript n times x to the nth plus a subscript n minus 1 times x to the nth minus 1. This is just a definition that the book gave you in terms of what the polynomial is. Okay. A subscript 1 times x plus a subscript 0. So this is the definition of the polynomial that we already have at the beginning. Okay. So for large value of x, okay, either positive x or negative x, whatever you choose, of this polynomial, the end behavior is what it looks like, okay? So resembles. So this polynomial function resembles. Give me another word that means the same as resembles. Yeah, looks like, right? Behave like. Okay, that's what it's called, end behavior. Resembles what? What does it resemble? What does that whole shebang, ugly polynomial, what does it look like? What do we use? For large values of x, what does it look like?
It would be like the largest number.
Yeah, it would just look like this very large first term, okay? Excuse me. So, it would just look like y, or sometimes we use f of x, right? A sub n times x to the nth, okay? It's always that first term, okay? So think about this, okay? Let's pretend that this is Bill Gates' money. This is all the money that he has, okay? He goes around, he's going to give you $1, he's going to give you $2, he's going to give you 1,000. He's going to even give you like $1 million over here. In the end, Is he still going to have a lot if he keeps this piece right here? Yeah, that's what all of this right here, adding and subtracting small chunks doesn't really change a person like overall wealth, like in terms of if he has so much, okay? That's all that end behavior and power function means, okay? One example, and we'll call it a day. Okay, determine which function is a polynomial. State the degree if it is. Explain if it's not. Okay? What's a polynomial? It's a function. It's what kind of function? What kind of function? What does it have to be called a polynomial? You guys a moment. I have no idea what you're saying. You have to raise your hand and tell me. Multiple parts. Poly means multiple parts. Okay. What else? There are special characters that you have to be a polynomial.
It has terms which are real numbers.
Ooh, what terms?
Non-negative integers.
What has to be non-negative integers? N, which means what? N in this problem means what? An exponent. Okay. Polynomial. It's going to deal with multiple terms. Sometimes multiple terms can be adding zeros to a bunch of it. Okay. N means power. And the power for each equation has to be what? Non-negative integer. Or in other words, can I say positive integers? Yeah, that's also okay to say. All right. A, 5x squared plus 4x to the 4th equals f of x. Is that a polynomial? Yeah. How can you tell? Because both powers are what? Positive integers. So yes, that is a polynomial. What's the degree? Because you say yes. 4. Great. Write it out. So this is a yes. And degree is 4. B, boy. F of x equals 3 minus 5 over 2x.
No. Yes.
It's still yes?
Yes.
How do you know it's yes? Is 5 over 2 a degree? A power? No. Remember, it is not a power. It can be anything it wants to be. But what's the power here? 1. The power is 1. Is that a positive integer? For sure. So that's a yes. And the degree is 1. Okay. Okay, C. Oh. 2 minus 5 divided by x. No? Why not? It's technically x to the negative 1. How can you see? Where did that come from? It's on the bottom. Okay, let's review really quickly of what that means. If you have x to the negative 1 power, class, remember in algebra 1 and algebra 2, we try to convert back and forth. How do you make that? What do you do? 1 over x. That's right. Okay. So that's always true. So now we have x on the bottom. If we were to rewrite it, okay, so into a non-fraction, would you agree that this looks like 2 minus 5 times x to the negative 1? So is that a polynomial? No. And that means you have to give me a reason. No, because what? Okay, no, because degree is a negative integer, right? Degree is a negative integer. Okay. All right. D for dog. D for dog.
No.
No? How can you tell? An exponent is a fraction? Okay. Can I FOIL that? What if I FOIL? Would that change it? Okay, so that's going to be x, right? Minus rad x. Where's the fraction? I don't see any fraction. What are you talking about? Square root. Okay. Square root, it's what? Equivalency to? X to the 1/2. Yes, that is true. Okay. So this is like that. Okay, so it's no. Because the degree is negative? Is that right? Because degree, or the power, whatever you want to call it, is not an integer. Okay. All right, you and your team, figure out, check for you, A, B. A and B. I'm going to get your deck of cards so I can shuffle. And I'm shuffling.
Wouldn't it be no? Because I mean, for would it be x to the negative 1 over x to the negative 2 minus 4? B is no 2.
All excellent. Degree and excellent. Because all excellent. The whole formula. No excellent.
Yeah. Like, I
You guys are done? A and B?
Oh, I didn't see 7 over 2. I just saw 2 and I was like, oh.
That's what you guys see. I went to Cal Poly Slow. UCI was one by school. So it's kind of space. Oh, you done? Yeah. All right, here we go. Apple. Nathan. Polynomial or not?
No.
Why? What's the reason, Nathan? The degree is negative. You guys agree? Yeah. Because if x is in the bottom, you can always rewrite it, right? As x to the negative 1 power, right? B for boy. Izzy.
No, because the degree is not an integer.
Yeah, look at that little guy, right? It's definitely not an integer. All right, that's a wrap.